Right, we are doing Unit 6, Lesson 7, and we're talking about the properties of parallelograms, and the unit is on triangle proofs. So it's going to involve triangles and doing proofs involving triangles. But we need to start with the definition of a parallelogram. As the word suggests, parallel is the root, the word. Para, to come alongside. Parallelogram. Gram or graph is right. So a parallel right. It literally means that the two opposite sides are parallel to each other. So BC is parallel to AD and AB is parallel to CD. So let me write that out. BC, segment BC is parallel to AD and AB is parallel to DC. Okay, and there are a number of properties of parallelograms that we will want to use and prove. One of them is a property you may already be aware of, and that is that opposite sides are congruent. Okay, so let me make a new slide here. Opposite sides are congruent. So BC is congruent to AD, and AB is congruent to CD. They're the same length. Okay. So if I was told that this length is 14, then this length is also 14. If I was told that this length is 8, then this length is also 8. Okay. But let's go ahead and go through and do a proof of that rule. And the proofs involving parallelograms all involve drawing diagonals. So I'm going to draw a diagonal, dia meaning through, diagonal. Okay. And you'll notice it divides a parallelogram ABCD into two triangles, right? So we're going to prove opposite sides of a parallelogram are congruent. Okay? Literally, we're going to prove that BC is congruent to AD and that AB is congruent to CD. Okay. So we're given that it's a parallelogram. So we were given parallelogram ABCD. Draw a diagonal AC. Okay, that's just describing what we have in detail. So let's see if we can figure out the triangles. Okay, I have a shared side, so I know that AC is congruent to itself. AC is congruent to AC by what rule? By the reflexive property. Reflex. Not reflective, but reflexive. It's like when the doctor hits your knee with a rubber mallet. It's a reflex by the reflexive property. Every time you make a statement, justify it with a rule. Okay? And let's see what else we know. I may recall that when two lines are parallel and they're crossed by a third line, that these two angles are congruent, alternate interior angles. And so this angle is congruent to this angle by that rule. Likewise, this angle is congruent to this angle by that same rule, the alternate interior angle theorem. So angle BAC is congruent to angle. BAC is congruent to angle DCA. And angle DAC is congruent to angle BCA by the alternate interior angle theorem. Alternate interior angle theorem. Okay? And so look at what I've got. I've got an angle congruent to an angle. I've got a side congruent to a side. I've got an angle congruent to an angle. So by angle, side, angle, these two triangles are congruent. So triangle, ABC, is congruent to triangle. Now ABC, they're congruent by rotation about the center point. So ABC goes with CDA, triangle CDA, by angle, side, angle. And what do we know about congruent triangles? They have corresponding congruent parts. So therefore, that's what these three dots mean, therefore. Makes you wonder what they're there for. Therefore, AB is congruent to CD, the corresponding parts, and BC is congruent to DA or AD, since corresponding parts of congruent triangles are congruent. QED, quod erat demonstrandum, I said it, therefore I proved it. So we've just proved that the opposite sides of a parallelogram are congruent. And I want to see if I can squeeze in one more here, and that is proof that opposite angles are congruent. Okay, so let's go ahead and get rid of this here and add a new layer. Prove opposite angles are congruent of a parallelogram. So we're going to prove that angle B is congruent to angle D. Okay? And I can do it very much similarly to prove angle C is congruent to angle A. It all just depends on how I draw my diagonal. So we were given, always start with what do we know? We were given parallelogram ABCD. Draw diagonal AC. So let's draw diagonal AC. And by the same reasoning as before, we can prove the triangles are congruent. AC is congruent to itself by the reflexive property. Okay? And angle BAC is congruent to angle DCA. Angle BAC is congruent to angle DCA. And angle BCA is congruent to angle DAC. Angle BAC is congruent to angle DCA. By the alternate interior angles theorem. Okay, so guess what we've got? We've got an angle congruent to an angle, a side congruent to a side, an angle congruent to an angle. And we now know that triangle ABC is congruent to triangle. Again, they're congruent by rotation about a center point of 180 degrees. So picture that going around. ABC is congruent to CDA. by angle, side, angle. Therefore, corresponding parts. Therefore, angle B is congruent to angle D since corresponding parts of congruent triangles are congruent. Quod erat demonstrandum. I said it, therefore I proved it. Okay, and just to sum this up, what does this mean? This means if I'm given a parallelogram, if I'm given a parallelogram and I'm told that this side is x, maybe 2x or 3x, and this side is 2x plus 5, that they are equal. 2x plus 5 equals 3x, and you can solve. 3x minus 2x is x, and x equals 5. Okay, and you can substitute back in. 2 times 5 plus 5 is 10 plus 5 is 15. 3 times 5 is 15, so both sides are 15. So you can set up and solve equations like that. Or, here's another. Opposite angles are congruent. So you can set up a problem like this, where you say 4x and 2x plus 6. So you could say 4x equals 2x plus 6. Subtract 2x. 2x equals 6. Divide 2. X equals 3. 4 times 3 is 12. 2 times 3 plus 6 is 6 plus 6 is 12. So each angle is 12 degrees. Okay, so those are kinds of problems that you can end up doing. Opposite angles are congruent and opposite sides are congruent. Okay, and aside from that, you want to be aware of how to prove. And I've run out of undos. All right, that's all for this video.